All right, so the next two steps may get a bit entangled, so just follow very carefully what I do in order to solve our equation from the previous video. Okay, so the first two steps, or the two steps in the LU decomposition, first you need to decompose A into L and U, our lower and upper matrices. Then we want to use L and U to determine X for a particular B, and then this itself, determining X for a particular B, consists of another two steps. So the first step is, first step is to use L and D to solve, or we use, forward substitution of L and B to solve for D, and then we back substitute D into the following equation: Ux minus D equals 0 to solve for X. So in matrix form, this looks like the following. So we start off with an initial matrix, A11, A1n to ANN. We split this up, we decompose it into the lower matrix, which has the form 1, L1, L21, Ln1, down to 1 with the zeros above. Now this is just it's kind of the inverse of the Gauss-Jordan method. So we would start at our row, our last row, and work our way up. Okay, and then the upper diagonal matrix would look like what we've already seen. U12 to UNN. Okay. This is the first step of the Gauss elimination process. We then take the lower matrix and use forward substitution. So we have LD equals B, which we know can be written as matrix L augmented B to solve for D. And then we go and use back substitution into the equation. So Ux minus D equals 0, or Ux equals D, which is simply matrix U augmented D will give you X. So now you can see that once you've completed the first step of the LU decomposition, that is decomposing A into L and U, you can then continuously update or change the constant matrix or vector B and solve for X using the two-step approach. And now I want you to apply this to our truss example that we came across in the introduction.